question number 11 asks you to draw a 2D gel for the mixture of peptides shown below. Make sure to specify which direction of the gel is which and where the electrodes are located. All right, so this would now be our SDS page gel, or our 2D gel. All right, so I've drawn the isoelectric focusing gel on the top and our SDS page gel here on the Y direction of this gel. All right, now I've labeled for the IEF gel, the isoelectric focusing gel, which side has which pH to it. All right, now similarly, with the SDS page, I should probably label it as high molecular weight and low molecular weight. That might help me out a little bit. All right, and so let's start with the SDS page with the electrodes here. All right, so with the electrodes on SDS page, our proteins always move towards the positively charged electrode because they're coated with SDS. So when we're running the SDS page, the negatively charged electrode would have been on top and the positively charged electrode would have been on the bottom. All right, isoelectric focusing is a little bit trickier to understand. Now, so remember the gel basically has this pH gradient in it. All right, so as our proteins, if they're, let's give you an example here. If a protein has a pI of 4, we'll go with protein A here. All right, and let's say I loaded on here close to pH 2. Well, what is its charge at that pH? What is the charge of this protein at pH 2 if its pI is 4? Well, it has a positive charge. And we want the protein to move to the region where it is going to be have a net zero charge. All right, so we want it to move towards the right here, which means that the right side of our gel must have a negative charge to it, and the left side of the gel must have a positive charge. Now I could do the same thing. I could take the same protein, let's just say protein A from our up here, all right, with a pI of 4. And let's say I put it, I load it in here at pH 10, right? So in this case, the pH is much greater than our pI, and so our protein will have a net negative charge. And we want it again to move towards the pH 4 region, so we want it to move to the left. All right, and so because of that, we need the positively charged electrode to the left. So it doesn't matter which way you think about it. You can figure out basically that the positively charged electrode has to be on the left, negatively charged has to be on the right, the way I've drawn the gel here. All right, now that's the way the gel is set up. Now, now for figuring out where the proteins are on the gel. Well, we have two proteins here with a pI of 4, another one with a pI of 5, and another one with a pI of 8. Well, that will show up as we move in the X direction here. So we should have two proteins at approximately a pI of 4, another one here at a pI of 5, another one further down at a pI of 8. Now, all right, the question is, how far down do they go? Well, at pI of 4, we have two proteins, and they have two different sizes to them. So one is 22 kilodaltons, and our smaller proteins move further. So this will be our 22 kilodalton protein. All right, and our 45 will be up here. So I'm going to label these with the letters that were used in the table. So protein B will be there. Protein A will be right there. All right, then our pI of 5 protein has the higher molecular weight of 45. So this is protein C, and then protein D will be right here because it has a higher pI of 8, but the lower molecular weight of 22. So this is what your 2D gel should look like.